In this video, we're starting trigonometry, and in trigonometry, we always start with the unit circle. Why unit circle? First of all, when we think about angles in geometry, or when we had it in geometry, the angles were something between 0 degree and 180 degrees. In real life, there are discussions of rotation or motion. And rotation comes, let's say we start here, and I can go around a few times and then end up anywhere around here or here, over here. And if you notice, the first motion that I did was clockwise. And so that would be a positive number, and obviously that's more than 180 degrees. It was at least a full rotation, a full revolution, therefore more than 360 degrees. Now, also, if you go counterclockwise, you can go however you want, and then that would be a negative angle. So that's because of the motion. Another thing is that the unit circle actually helps us connect angle to length easily, and that comes with radian. And so instead of expressing angles in degrees, we express angles in radian. And so what is radian? And radian is let's say this is angle T, and this is the unit circle. That means that the radius is 1. Then the length of this arc length over here, is the angle in radian. How do I figure this out, though? Let's see. What I know about the unit circle, so let's say that I know angle T in degrees. I have one piece of information about unit circle. If I go one full revolution around the unit circle, I have traveled 360 degrees. The other piece of information that I have, that's actually true around any circle. If I travel 360 degrees around the unit circle, the arc length is going to be the circumference of the circle. What is the circumference of any circle? That is 2 pi times r. When radius is 1, that becomes 2 pi. Now let's look at the angle T. T in degrees is a fraction of 360 degrees, so I can set it up as T in degrees is over T in radian is going to be equal to 360 degrees over 2 pi radian. Now, to solve one way or another, I'm going to start, let's say, with T in degrees, then it's 360 times T in radian divided by 2 pi. Simplifying this, I get 180 T in radian divided by pi. And the other way around, if I want to find the T in radian, knowing the T in degree, I get, that's the main goal in the beginning. So T in radian is T in degree times 2 pi divided by 360. So, truly, I do not recommend memorizing either of these formula. One would be T in radian is equal to pi T in degrees divided by 180. And the other one would be T in degree is equal to 180 T in radian divided by pi. I do not recommend memorizing these two. Just remember the ratio of 360 degrees to 2 pi is the same as the T in radian divided by T in degrees divided by T in radian. And that then you can apply in either of these formulas. So a few of the well-known angles in degrees that we used to use in geometry a lot, I would like them to be converted in radian. So how do I go from T equal to 45 degrees to the radian value for the angle? And that would be T in radian is equal to pi times 45 degrees divided by 180 degrees. And then when you simplify this, 45 times simplifying 180 is 4 times 45. Therefore, they simplify to, let's write it down for now. And then you simplify these and you end up with T in radian is pi over 4. How do I do T equal to 30 degrees? Again, with the formula, I'll have T in radian is equal to pi times 30 degrees divided by 180 degrees. And then you simplify, remembering that 180 degrees is 6 times 30. And so they simplify and you end up with T in radian is equal to pi 6. So far, 45 degrees is equal to, let's write this down, 45 degrees is the same thing as pi 4th radian. And here, 30 degrees is equal to pi 6th in radian. Now, for T equal to 60 degrees, let's calculate. T in radian is pi times 60 degrees divided by 180. And that is pi times 60 degrees divided by 3 times 60 degrees. And then this would be T in radian is equal to pi 3rd. And so 60 degrees is equal to pi 3rd radian. With the same method, I can also calculate, and I'm skipping that one. And if the T in degrees is 90 degrees, then T in radian is going to be pi half. These are important information that you want to keep in mind for the rest of the trigonometry course. Of course, converting is fine, but eventually this should be memorized by you. The next part is defining sine and cosine on unit circle, and then calculating the sine and cosine for the angles that are on the board. So we're continuing with definition of sine and cosine on the unit circle. Let's do a little bit of review from what we've done so far. When we're discussing an angle on a unit circle, we're discussing the angle that is measured from the initial side or x-axis and to the terminal side and in counterclockwise. So for example, this angle made between these two sides is in radian is this value starting from the initial side going to the terminal side. Let me introduce a new Greek letter to you. A sort of upside oval and a line through it, and that's theta. So theta in radian is the length on the unit circle traveled from the initial side to the terminal side of the angle. And if it's counterclockwise. If it's clockwise, then the value would be a negative. So if you have a theta down here, for example, or let's call it something omega, this value is the negative of that length. Now, the discussion is what are sine and cosine of theta. Sine and cosine of theta are related to the terminal point for the angle. What is the terminal point? Terminal point is where the terminal side intersects the circle. And that terminal side, terminal point, has an x and a y value. And I would like to show that in here. So if I drop it perpendicular to x-axis, this is the x value, and that is the y value. Sine and cosine of theta, so let's start with cosine of theta is equal to that x, and sine of theta is equal to that y. How do I memorize this? Cosine starts with C, sine starts with S, C in alphabet comes before S, X and Y, X comes before Y, so X goes with C, Y goes with S, because the order of their alphabetic order, X comes before Y and C comes before S. That's how I memorize it. This is important. It turns out that as long as we're in the degree mode, the same thing happens. Right now I wrote cosine of theta and R on top. That means that theta is in radian is equal to x. Sine of theta in radian is equal to y. If you have the theta in degree mode, and then you also can plug it in and it will be the same formula for it. Now that we figured this one out, we just defined, this was the definition. The next step is to actually show the sine and cosine for a few angles that we're more interested in, or more famous angles, basically. As you saw right before this page, that we try to figure out when theta in degree is equal to 45 degrees, we figured out theta, that this is going to be equal to, in radian, pi fourth. So one thing that we would like to do is to find sine and cosine of this important angle. First thing is, so theta is about 1/4 of the, 1/2 of the first quadrant, basically. If you divide, so this is 45 degrees or pi fourth. Then if I drop a rectangular perpendicular to x axis, I'm sorry, what I observe is that this angle over here is 45 degrees. This angle is going to be 90 degrees. This is a triangle, and therefore let's name this O, and name this A, and name this H. So OAH is a triangle. One of the angles is 45 degrees, the other one is 90 degrees, the third one should be 45 degrees. And this means that AH is going to be equal to OH. So AH is equal to OH. What does that mean? That means X is equal to Y. Use the Pythagorean theorem. To calculate the X and Y. How do I use that? According to the theorem, X to power 2 is plus Y to power 2 is equal to the hypotenuse to power 2. Again, where are we? We're in unit circle. So X squared plus Y squared should be equal to 1 to power 2, unit square. According to this rule, X should be equal to Y. So I can replace Y by X. And then I have one equation, one variable. I can solve for X. So 2x squared equal to 1. That gives me x squared is equal to 1/2. That gives me that x is equal to plus minus square root of 1/2. And this one is obviously a plus, therefore I can get rid of the negative sign. And then the other part is that this would be equal to square root of 1 over square root of 2. Square root of 1 is 1. I can rationalize this to get square root of 2 over 2. So x is equal to this. Also, y was the same value. So I found both sine of theta and cosine of theta in this situation. So let's rewrite it over here. Cosine of pi fourth is equal to square root of 2 over 2. Sine of pi fourth is equal to square root of 2 over 2. The next interesting angle that I want to discuss is the 60 degrees. So 60 degrees about here. Let's write theta in degrees equal to 60. Theta in r, according to our calculation, is pi. So to find the sine and cosine of 60 degrees, or pi third, I still know I'm supposed to drop down and perpendicular on the x-axis, but first I start with this. I connect the terminal point to the initial point. And then I observe this length is 1 because it's unit circle. This length also is 1 because that's another radius, and that's in unit circle. I have one angle that is 60 degrees. These two being 1 means that these two sides are the same in the isosceles triangle. The other two sides should be equal. So if I call this T and call this T also, 2T plus 60 degrees should add up to 180 degrees. That makes 2T is equal to 120 degrees and T equal to 60 degrees. So that means that the isosceles triangle that we have in here is also an equilateral triangle. Having an equilateral triangle in here helps me understand when I drop down a perpendicular to x-axis, that also is the mean for that side. That means that it's going to break this side of the triangle into 2 equal pieces. Now I'm going to erase this again, start over. This triangle built over here is an equilateral triangle, and therefore the perpendicular over here is going to divide this side into 2 equal pieces. This side was 1 because unit circle, 1 unit. Therefore, this value has to be 1/2. So you find that that is 1/2. Now, knowing this was x value. So x is equal to 1/2. The next thing that we want to figure out is y. To figure out y in this triangle, H, A, O, OHA is a right triangle, so I'm going to use Pythagorean theorem for the right triangle there. And that would give me 1/2 to power 2, which is x, plus AH, which is y, to power 2 is equal to the hypotenuse, which is 1. Solving this will give me y squared is equal to 1 minus 1/4, 3/4. Taking the square root, y is equal to square root of 3 over square root of 2, square root of 4, and plus and minus. Again, this is obviously a plus value because x and y in here are positive. Therefore, I can eliminate the negative sign. This entire process is allowing me to say that cosine of pi third is equal to 1/2, and sine of pi third is equal to square root of 3 divided by 2. The next step is to find sine and cosine of pi sixth, pi half, and 0. Now I'm calculating the sine and cosine of angle 30 degree or pi sixth as we calculated. How do we start with this one? What I do is I find a mirror image of the terminal side over x-axis. So I reflect the terminal side over the x-axis. That means that this angle is also the same thing as in geometry, the same thing as that other angle. And then so they add up to 60 degrees, and then I connect these two. This is 60 degrees. This side is equal to this side equal to 1 because they're both radii of the unit circle. Again, this triangle ends up being an equilateral triangle. Equilateral. That means that by the symmetry, since we have this side, this length, also equal to this length, that means that in an equilateral triangle or any isosceles triangle, what the median of one side also is perpendicular to that side. Therefore, this is a right angle. That being a right angle means that this length is actually y for the point, the terminal point. The other part is that we know this is an equilateral triangle, so this length is 2y. 2y is equal to 1, therefore y is equal to 1/2. The other part is to figure out what x is. Also, I know this length is going to be equal to x, or the length of the median. But then in this triangle, OAH, Pythagorean theorem, on OAH will let me know that OH, which is x to power 2, plus 1/2 to power 2 is equal to the length of the hypotenuse in this triangle, which is 1 to power 2, results in x squared is equal to 3/4. X equal to plus minus square root of 3 over 2, but we know that the minus sign will not work in this situation. So x is square root of 2 over 2. Therefore, we found that cosine of 30 degree or pi sixth is equal to square root of 3 over 2. Sine of pi sixth is equal to 1/2, or y is 1/2. This is another piece of information added to the other two pieces of information. The last thing that I want to do, finding the angles in the first quadrant, is the angle pi half and angle 0. So if you look at the unit circle, you notice that angle 0 happens right here. Start from the initial point and don't move. You end up right here. So x and y over here is of interest for angle 0. So cosine of angle 0, it could be 0 radian or 0 degrees, is equal to this x value, which is the radius, equal to 1. Then sine of angle 0 is equal to the y value for this point, which is 0. Now let's find sine and cosine of pi half. Pi half is 90 degrees, and we know it's going to be over here. Oh, this is pi half. X value for pi half is 0. Y value for pi half is the radius and is equal to 1. So cosine of pi half is equal to 0. Sine of pi half is equal to 1. So the next video is about angles that are not in the first quadrant and their sine and cosine values.